So 12.2, number 52. We have 3x minus y plus 2z is 4. 2x plus 2y minus z is 10. And x minus y plus 3z is negative 4. And you guys know a matrix for this?
Yep.
Okay. Can you tell me?
3,
negative 1,
3, negative 1, 2,
4 equals 1.
4.
Line
2.
4.
Line 4. Okay.
2, 2, 2,
2, negative 1,
is 10.
and 10.
Okay.
1, negative 1, 3, and negative 4.
Okay. Perfect.
All day.
Done. Okay.
Can we switch the last one and the first one?
Okay, we totally could. I would advise against it.
So
Okay.
can we switch
The
the
reason I would, hang on, that was actually a really good suggestion, and that's exactly what I tell a computer to do.
What would you say?
That said, I am worse with fractions, right? So I'm not going to multiply this middle row by a half because I'll end up with fractions here and here.
Mm-hmm.
I'm going to settle for dealing with bigger numbers to avoid
Do you
doing
want to
fractions.
multiply the bottom row by -2?
Perfect. What's your?
I was gonna say we could put the top, the bottom one on top.
So you can get this.
So one is already set.
Yeah, we could totally do a row exchange here. I'm not going to.
Okay.
Not for any particular reason.
Well, it's already set, so.
So I'm going to do row 3 turns into what? What was your suggestion, Ange?
Negative row 3 multiplied by -2, so it turns into -2, positive 2, -6 plus 4.
Plus
Positive 4.
positive 8. Whole row, right? All right. And what are you going to do the second row and first row? Nothing? So I got 2, 2, minus 1, 10 in the middle, and 3, negative 1, 2, 4 on the top.
Oh yeah, sorry.
Say when we hold row 3, like -2 or whatever.
That's what we're
Oh,
Just
this
say
little guy?
times it.
Yeah.
Yeah, so all I'm saying with this little thing is row 3 turns into -2 times row 3. That's just for me to keep track of what the heck I did there, just in case I screw up later. I want to go back and like, oh, what did you do between, you know, if I just do this, it's not obvious what the heck I did in between those
Yeah.
steps. So then what's your next step going to be?
Add the bottom two rows together and put the bottom row.
Perfect. So to write that as arrows, I'd say row 3 turns into row 2 plus row 3. You guys see that?
Yeah.
Do you guys remember back to when we were doing Algebra 1? Especially those of you who had me. I was actually writing stuff like this down on the sides. All right, so what happens to the first row when I do that?
Stays the same.
Stays the same. So I got 3, negative 1, 2, 4. How about your middle row?
Stays the same.
Stays the same. So I got 2, 2, negative 1, 10. And how about your last row now?
So 0, 4, negative 7,
0, 4, negative 7, 18. Perfect. Cool. All right, now what thing are you targeting next?
the row above. The first, the X is in the
One is
second
0
row.
where the
Yeah,
2 is.
I want a 0 where this 2 is, right? The X is in the second row. Perfect. So how am I going to get rid of that 2 there? Okay, I need the least common multiple of 2 and 3. So I have to use the first row, right? You guys all see that?
Mm-hmm.
If I try to use this row to eliminate that 2, I definitely can't, right? Because no matter what I do to this row, I got a 0 in that spot. Cool?
Mm-hmm.
So what are you going to do to make it so you've got 6s?
You're going to multiply 3.
Okay, so row 1 is going to turn into twice row 1, and row 2 is going to turn into 3 row 2. Ah, negative 3 is an even better idea. Okay. Okay, cool with it? What about the last row?
Stays the same.
Stay the same. So you got 0, 4, negative 7, 18 in the last row. How about the first row? What do you get?
6, -2, 4, 8.
6, -2, 4, 8. Cool. And the middle row? -6, -6,
3, -30.
3, -30.
I see.
Okay, so you're distributing a -3 through all of those pieces, right? Okay, then what are you going to do?
Combine the first
Add
row.
those first 2 rows and put it in the second row.
Perfect. So row 2 is going to turn into row 1 plus row 2. So what happens to the third row?
Stays the same.
Nothing, you're just going to carry it along. So I got 0, 4, -7, 18 in your third row. How about your second row?
0,
0, which was the point, right?
correct.
And then
-8,
-8, 7,
7.
-22. Cool. And your first row
stays the same.
stays the same. So 6, -2, 4, 8.
Why doesn't it go back to 3, -1, 2, and
It certainly could. You guys see that?
4?
Yeah, because it's the same.
Yeah, this
It's the same,
6,
but multiplied by-
-2, 4, 8, right, contains the
Three,
same
yeah.
information as 3, -1, 2,
Okay.
4.
Yeah, you just divide it by 2.
Yeah, you certainly could divide it by 2.
Okay.
That might actually be a really good idea. Okay, so now what do I have here? I have an equation that's got x, y, and z in it, right? That's my top one.
Yes.
My middle one's got
Y, Z, and number.
y, z's, and a number. And my bottom one has
Y, Z, and number.
y, z's, and a number, right?
Yeah.
No, 4 to 1, right?
Oh, that's an even better idea. You guys see that?
Squish 'em.
So my
Thanks.
technique, right, would normally I would be looking to smash this 4, right?
Okay.
But if I notice that if I just add those last two together, right,
Uh-huh.
what will I know about?
Or,
Yeah, I'll only have one thing left.
Yeah.
I'll have y's left, right?
or
So I'll know what y is. And then I can do some back substitution to get out of this.
Okay.
You see that? So, can you, Angela, this was your idea, so can you tell me what you want to do in terms of row operations?
So I want to take row 2 and turn it into row 2 plus row 3.
Okay, so you want to store in row 2 plus row 3? Okay, that seems legit. So I got 6, -2, 4, 8 in my first row. Or the alternative, right? Or 3, -1, 2, 4. And then what do you got in your middle row now? 0, -4, 0, -4. And in your last row, what do you got? 0, 4, -7, 18.
So you kept the bottom row the same, but no, what did we do for, oh, minus the 4?
Yeah, so
What did
what,
we do for the second row?
what Angela said she wanted to do was take row 2 and replace it with row 2 plus row 3.
You're adding.
Yeah, we're squishing these two together and putting the result in the middle.
Okay, so you're adding those two together.
Yep. So I took row 2 and row 3, I added them together, and I put the result in the middle row.
And now we know
Got
our
it.
Y, which is 1.
And now I know what y is, right? So this tells me immediately that y is 1. Now what could I do with that information?
So plug it back in.
I could plug it back in, or what else could I try to do?
Like reverse.
You could plug it into the bottom one, get X, and then, or
Plug it into the
Z.
bottom one to get z, and then I can take those two pieces of information,
And then
plug them in the top one and get x, right? Do you guys want to do that, or do you want to play more matrix games?
No.
I
Let's
do-
do that.
Okay.
do more
Okay, so let's plug them back in.
okay.
Seems like that's what people want to do. So once I found y, I got y as 1. Now what's my bottom equation represent?
4y plus or minus 7z equals 18.
Okay, so I got 4y minus 7z is 18, but I know y is 1. So this is really
4 minus 7z equals 18.
4 minus 7z is 18. So what are you going to do now? Subtract 4. Okay, so I got negative 7z is 14. So then you'll divide by 7, maybe negative 7. And we'll get, so z is negative 2.
No, divided by -7.
As Ethan said, divided by a negative.
So now you can plug those two, the y and the z.
Okay, so now I know y is 1 and z is negative 2, and I go
Plug it to the first one.
plug it into, yeah, you've got lots of options again. So you can plug it into the equation reft by 6 minus 2, 4, 8. Or you can plug it into the equation reft by 3 minus 1, 2, 4.
Or you can do one of those.
Or you could plug it back into any one of the originals.
I'd go the bottom one. Though.
Yeah.
Bottom one on the original?
Yeah.
Okay. So that one says I have x minus y, oh, y is 1, cool, plus 3
Times negative 2
times negative 2
equals a negative 4.
equals negative 4. So that gives me x minus 7 is minus 4.
Plus 7.
11.
X equals 3.
Oh, sorry. Oh, no.
So x is 3. Oh, wait. I started to circle that, but what's the answer?
X equals 3, y equals 1, z equals negative 2.
Okay. And
Oh,
before that was a point, right?
Oh,
No,
yeah,
y?
because it's 3.
so this is
Yeah, so it's a three-dimensional point. Right? Welcome to the world. We're now doing math in the world. Crazy, right? We're not going to just do math on paper anymore. It's the same shit with one more thing, right?
Yes.
So how would I write a point with 3 things in it?
X-ray, y,
Yeah, x, comma, y, comma, z. So I would write this one as 3, comma,
1, comma, negative 2.
1, comma, negative 2. Bam.
Draw that on
I
your
know, draw that.
And he is.
Oh, yeah.
Well, because of course you can draw this, right? This is a point in the world.
Why is x the... Okay, so z
Why
and y are
is
the
the
point.
A?
I just picked the labeling, right? You guys want a different labeling?
Yeah, I don't like that.
But the Z is the.
Go it that
Anything.
way?
Yeah.
That doesn't
Yeah,
make
that
any
works.
sense.
I
How that
want the
works.
Z to be the diagonal.
Yeah.
Like,
Yeah. It's not diagonal.
It's not diagonal.
oh, the.
So what
Fill
these
it out
mean,
that way.
right,
If you
were
are
looking
this
down on
way,
it, you
this
wouldn't
way,
see Z.
right? Left, right, front, back, and
up, down.
I
Up,
almost want to
down.
use like north, south.
So-
west.
Yeah.
No,
Almost.
it doesn't work.
yeah, you want to use north, south, east, west, right? But that's 2 dimensions, not 3. So you need like north, south, east, west, and
South, yeah.
up, down. Right? It's got to live in 3 dimensions. So if I thought about what this might mean, it might mean 3 over, 1 forward, 2 down. You guys see that? Anybody play Minecraft?
Yeah, kind
Yeah, if you turn on the coordinate system,
of. Oh.
right? They actually come in a
yeah.
north, south,
Yeah,
east,
yeah.
west,
Y,
and
then how high you are.
and an altitude.
What about in
Right?
space? How do you get up and down in space if you have no...
Yeah, you need a reference. So you need to pick what front, back, up, down, and side, side. But yeah, if you just kind of pick these to be whatever, this system works. Cool. So if I was going to try to graph this one specifically, I'd go 3 in the x, 1 in the y, right? So I need to go, okay, so that's like, here's 3, 1, 0, right?
-2.
So I need to go 2 down.
Now, would that be a line, a parabola, or what would the?
So this is a dot.
So it's just a dot.
Yeah, this is just a
Okay.
point. Now, back to the beginning here, what were we doing?
Yeah.
Well, what are these
Those
guys?
are all lines.
Those look like.
Or
They're
wait,
not
lines.
lines.
They're three-dimensional.
So they're, planes? Yeah, don't steal my thunder here. So they're planes.
Trains.
The reason they're planes is you could solve one of these for z, right? So let me
Yeah.
take the middle one for instance, because it's easy to solve for z, right? This tells you z is 10. Oops.
Minus.
How about z is 2x plus 2y minus 10?
You
Okay.
just subtract, you just,
Got it. I see
Cool.
what you're doing,
So this tells you what z is.
but not the next.
Really, we might think about this as a function of two variables, right? Takes two inputs and makes an output. You guys all cool with that? Okay, welcome to Calc 3, huh? And it's flat in both directions. You guys just trust me on that?
Yes.
So what's flat in two directions?
just get
Yeah, a piece of paper, a plane, right?
Oh.
So what's going on here is you have three planes, and we've found out where they intersect. So what does three planes look like? There's an easy example in this room.
It's almost a cube.
A wall,
The walls.
floor.
Yeah, so there's these funny walls, right, in here? And I can see this one. So here's a plane, right? This wall. Here's another plane, this wall. There's another plane that's the floor. Where do they all intersect?
Right there.
The corner.
Right here in the corner. You guys see that?
Cute.
So, wait,
that's
so if
the
it was
point.
4, where do they intersect?
So if there are four planes, they don't have to intersect.
Okay, so it's just 2 hit there, 3 hit there, 3 hit there.
So when two planes hit, they make a, you guys see that? When these two planes hit, this wall and this wall, what do they make?
One.
Yeah, they make a line. And then the other plane tells you which point on that line. You guys see that? If there's four, like the floor in here, the two walls, and like maybe this one, right? Do they all hit in the same spot? No, not in general.
So what would,
So there's some analogs to some stuff we know.
because if we're trying to answer where all these points hit, then if we have 4 equations, then how does that make any sense if we?
Yeah, so
try to fail that?
if you have four equations with three variables,
No,
it's
4
not going to make
equations with 4
sense.
figures. Okay.
So if you have four with four variables, then it gets a little bit funky in terms of spatial
Should I
interpretation.
just not even worry about that?
I would not worry about that right now.
Okay.
Is
Good
it
enough for me.
possible, like the other ones, like where they won't touch though?
That's exactly the question I wanted to answer. Yeah. So is it possible, can you guys see three planes in this room that don't intersect at a common point?
You could just.
Yeah, there's a whole
Yeah.
mess of them, right? So there's actually a couple ways for this to happen, right? Like we have the example of the floor, the table, and the ceiling, right?
Yeah.
Those clearly don't intersect. You guys list me another triplet that don't intersect at one point? There aren't those three in different. So don't tell me the surface of a chair, the table, and the floor, right? That's the same thing.
Door, table, and ceiling.
Yeah, this is-
Yeah.
Yeah, any one of the verticals, right? The floor and the ceiling. You guys see that? So we found one way that was like stacked parallel planes. Those don't intersect. You guys see that? But then there's also things like this, where I've got one plane and right, two stacked planes. Those don't intersect at a point. So if we
There's
tried
no
this in the matrix, do you guys know what we'd see?
We can get like you can't solve it.
Yeah, we get can't solve it.
What's it called?
How does a can't solve it look in one of these?
You don't get any.
It's like you can't zero it out. Oh, all zeros.
All zeros. So. All
Oh,
zeros in
something
a
which
number.
wouldn't
Yeah,
make
'cause you can't really
sense.
cancel it.
Yeah, so can you guys tell me what, so that's
If it's like 1, 1.
what it would mean for planes that don't intersect at a common point, right? This would give you no intersection.
So that means like if there's three, that all three of them aren't intersecting? Or
But
just
two can
the
still,
first?
two can still intersect, because the floor and the,
Yeah, two can still intersect, they don't have to, right? So in this case, you'd actually get 2 rows of 0 in a number, and in this case, you'd only get 1. You guys see that? What would it mean if things were like stacked? So if I had one plane and then a same one, and then another?
they all have
Be like
equal each other,
infinite?
right? They'll all be like-
Oops, that's a really crummy plane.
Like a deck of cards, like,
So what I mean is,
If
like,
there's two cards.
the tabletop, my 3 planes are going to be the tabletop, and this wall.
Then two of the equations would be those stars.
Yeah, 2 of the equations would be the same, so what would you see in the matrix?
Like,
It cancels out like immediately,
yeah.
Uh-huh, something could cancel out immediately, and so
All
you'd get a
zeros.
row of
zeros.
zeros. All zeros.
Even though number.
Yeah.
You guys see that? This is parallel, right?
Oh, cool.
Remember we did that one in the 2x2s? Right? Whenever we had 2 equations that were the same equation with kind of different labels, right? When the lines were parallel, we'd get a row of zeros because they'd be the same. Here, when we have this kind of not, well, parallel but not intersecting, right? We'd get this row of zeros and a number. Cool? So this happens a lot of ways. These are
Seems like
these are just for flat planes, right?
Yeah, these are
So-
purely flat. If you
so-
want to do things that aren't flat, you got to take calc 3.
Okay, so like 3 cubes together, like something like that would be really weird.
Yeah, 3 cubes
But they would still
together
only intersect
would be a
on
little
one.
strange.
Like if you can't use, obviously, is there a thing for like 3 parabolas? That would, well, not 3.
Yeah.
Okay.
There's a thing for this, and it's calc 3.
Okay.
So
Good enough.
this stuff gets complicated fast, which is why we're doing
we're just
the way.
rushing.
I just did it like.
Yeah, and this is okay because
Well, it makes sense.
we're gonna play with the simplest object there first, and then maybe later, once we have some more tools, we'll try more advanced things. But we need to talk about more advanced things. We need a little bit of like trigonometry and stuff, because we need some more
No.
functions to play in those spaces.
Fun.
Cool with these? So do you guys know what to do with 0, 0 number and with all zeros now? What does the all zeros mean? The zeros with a number means no intersection, right? What does all zeros mean?
And you have 2 planes that are the exact same.
Yeah, you have 2 planes that are the same. What does that mean in terms of your answer?
Means that there's only 2.
It's everything.
Different.
Well,
So-
everything in that plane.
Like, here's a plane, right, called the back wall. Another one of these and that wall, what do they intersect in? Yeah, they make a line, right? This crease in the corner. You guys see that?
Yeah.
So how many solutions do I get for that?
All wrong.
Yeah, it's not quite all real numbers, right?
You have to
But it's an
find-
infinite number of solutions.
So it's like talking about a plane then that just kind of theoretically goes on forever, so it's like not technically.
Yeah, these drawings that I'm making, right, are
They're
poor.
just, okay.
Really, they're just saying, well, the plane that's kind of suggested by this piece of paper, right? It continues in both directions
So,
forever.
okay.
Cool? Questions there?